أهلا وسهلا بكم جميعا. نرحب بكم في الويبينار الخامس من مشروع دليل الشبكة العربية لمدققي المعلومات من أريج، بدعم من الاتحاد الأوروبي وبالتعاون مع مؤسستي سايرن في لبنان وجوسا في الأردن، تحت عنوان كيف يمكن أتمتة عملية تدقيق المعلومات. معكم سجا مرتضى، مديرة الشبكة العربية لمدققي المعلومات AFCN من أريج، وصحفية استقصائية وصحفية بيانات، وسأدير هذا اللقاء اليوم الذي سيمتد على ساعتين من الزمن بين الساعة 6 و8 مساء بتوقيت عمان. كمدققي ومدققات معلومات في العالم العربي نجتهد كثيراً لتحقيق المحتوى المتوفر باللغة العربية، إما المنتشر عبر وسائل التواصل الاجتماعي أو عبر وسائل الإعلام، بالإضافة إلى تصريحات السياسيين وصانعي القرار والمؤثرين. ذلك يتطلب منا الكثير من الوقت والجهد. المصادر، البحث، بالإضافة إلى الأدوات، ونقوم بكل ذلك يدوياً. ولكن التقنيات تطورت كثيراً اليوم، ودخل الذكاء الاصطناعي بقوة إلى عالم تدقيق المعلومات. مؤسسات عديدة حول العالم بدأت باستخدام الذكاء الاصطناعي لمساعدتها في تدقيق المعلومات ومحاربة التضليل، كوكالة الأنباء الفرنسية وفول فاكت وتشيكيادو وغيرهم. كيف يمكن أتمتة عملية تدقيق المعلومات؟ وكيف يمكن الاستفادة من التكنولوجيا الحديثة والذكاء الاصطناعي لتطوير وتسريع عملية تدقيق المعلومات والمساهمة في مكافحة المعلومات الخاطئة والمضللة؟ أين وصل العالم في هذا المجال؟ وكيف يمكن أن نبدأ كمؤسسات تدقيق معلومات في العالم العربي خطواتنا الأولى باتجاه أتمتة عملنا؟ كل هذه الأسئلة سيجيب عليها فريق فول فاكت ديفيد كورني وكيت ويلكنسون خلال هذا الويبينار. فول فاكت هي مؤسسة بريطانية متخصصة في تدقيق المعلومات التي تؤثر بالرأي العام، كتصريحات السياسيين، صناع القرار، الصحفيين، وكل ما ينتشر بكثافة على مواقع التواصل الاجتماعي. ديفيد كورني هو كبير علماء البيانات في فول فاكت. انضم إلى فول فاكت في عام 2019 كعالم بيانات ومتخصص في معالجة اللغة الطبيعية. إنه يساعد في إدخال الذكاء الاصطناعي في أدوات فول فاكت لدعم مدققي المعلومات بشكل أفضل. كيت ويلكنسون، مديرة أولى للمنتج في فول فاكت. انضمت ويلكنسون إلى فريق تدقيق المعلومات الآلي التابع لشركة فول فاكت في عام 2022 كمديرة أولى للمنتج. تعمل على توسيع نطاق إنتاج الشركة التكنولوجي والتأكد من تطوره بما يتماشى مع احتياجات المستخدمين في جميع أنحاء العالم. كيف يمكن أتمتة عملية تدقيق المعلومات؟ هو عنوان ويبينارنا اليوم، الذي يمكن لكم خلاله طرح كل الأسئلة التي لديكم، وسأقوم بنقلها إلى المتحدثين للإجابة عليها. رجاء وضع تعليقاتكم في المكان المخصص للتعليقات، وأسئلتكم في المكان المخصص بالQ&A، وطبعا تفعيل خاصية الترجمة للاستماع إلى الويبينار باللغة العربية. ديفيد وكيت، الكلمة لكما، تفضلا.
Hello, everyone. My name is Kate Wilkinson. Thank you so much for the introduction, Saja. It is a great pleasure for my colleague David and I to be here to talk to you all today. We're very excited to share the work that we've been doing, share some lessons we've learned, the progress we've made, and hopefully answer some of your questions so that you can start thinking about automation, how it could fit into your organizations, and how it can support the work that you're doing. David is going to be sharing the slides for the presentation today. So we're just going to wait for those to pop up. Thank you, David. I am just going to request control from him so I can control them from my side. And I'm going to be making a concerted effort today to speak slowly, because I was told by one of the translators that I speak way too quickly, which is very true. And it's something I've been told a lot. So let's hope this goes to plan. So again, thank you for the invitation. We're very honored to be able to speak to you about automated fact checking and offer you some advice and some lessons from the journey that we have taken. So I think that the first statement that we can start with is really one that is central to Full Fact's mission, and that is that bad information ruins lives. FullFact is the UK's leading independent fact-checking organisation, and this is a statement, a sentence that we really put at the centre of all of our work. And we believe that bad information ruins lives for a number of reasons. First of all, it harms our communities by spreading hate and through misleading claims. It hurts our democracies by damaging trust in politicians and political processes in our countries. And it ultimately leads to bad decisions by disrupting public debate on the issues that affect us most, including the topics such as climate change, health, and public spending. A former colleague of mine at FullFact, Nivan Babakar, once described fact checkers as the first responders in an information crisis. And I think over the last almost 3 years now, with the COVID pandemic and the war in Ukraine, we've seen just how true that statement is. Fact checkers are often the first people to become aware of false information or widespread misunderstanding. In the same way that a paramedic hands over to doctors, fact checkers hand over to health organizations, governments of national statistics organizations to fill an information gap or to address a misunderstanding or the misuse of statistics. David and I are here to speak to you today, but we're part of a bigger team that is made up of colleagues who really have made the work that you're going to see displayed here possible. So you can see here some of our colleagues. Our work in the automated fact-checking team is led by Andy Dudfield, who is the head of automated fact-checking at FullFact. We then have our technical lead, Ed Ingold, as well as Simon Coltman, who is our front-end engineer. We are in the process of expanding our team, and I'll explain the reasons for that later. But by the end of the year, we plan to be a team of 8 people working on these challenges and problems and trying to find solutions to common problems that most fact checkers face. So, when it comes to FullFact's business on a day-to-day basis, we do a number of different things. First of all, we fight bad information in different ways. We fact-check claims that are made by politicians, public institutions, and journalists, as well as viral content online. And FullFact is a part of Meta's third-party fact-checking program, where we are paid by the platform to fact-check and rate posts to reduce the circulation of false information. And this is because, as an organization, we believe that all people deserve information that they can trust. We also follow up on our fact checks, and we do this by asking people to correct the record when they get things wrong, so that we can stop and reduce the spread of bad information. And this is part of what is called second generation fact checking, and something that I will expand on later. Thirdly, we are developing world-leading technology, and that's what we are here to talk to you about today. And we also do research to spot repeated claims and find out how bad information can be tackled at a global scale. Because FullFact really believes that although we are focused in our fact-checking on the United Kingdom, that we have a responsibility, and we really have significant plans to not just radically scale our work, but to make the work of fact checkers around the world much more impactful, more and much more faster and efficient. And then lastly, we also campaign for change. And we want to see bad information become rarer and less harmful. And sometimes we look at updating election laws to protect against misleading claims online. So FullFact has I was going to say long, it is long for automated fact checking. We have a long history in the space. We began developing technology to increase the speed and scale and impact of fact checking in 2015. And that was a year that we published a report called The State of Automated Fact Checking, where we highlighted, for example, one point, that being that international collaboration is vital so that the systems, when it comes to automated fact checking, work in several languages and countries. And that's something that you're going to see is really integral to the work that we've been doing and is really going to be a key part of our plans moving forward. In 2016, we received support from Google's Digital News Initiative for the first stages of our automated fact-checking work, and this funding assisted us in building our first prototypes. In 2019, we took quite a significant step forward. PhilFact was chosen from more than 2,600 nonprofits, social enterprises, and research institutions around the world as a winner of the Google AI Impact Challenge. And you can see in this picture a number of the organizations who were also winners of this grant. And we all traveled to San Francisco to receive a very intense week of training, mentorship, and support for the 3-year undertaking that we were about to begin. So based on the success of those first 3 years, Google has invested in further 3 years worth of funding into our automated fact-checking project. And we're going to be spending the next 3 years to radically scale our tools and to take them to the global fact-checking community. And that's one of the reasons that we were so keen to speak to you all today. And really what we're looking to offer and support when it comes to fact-checking organizations, potentially media organizations, as well as other information organizations, is that we really want to offer AI tools that are built by fact-checkers and created by fact-checkers, powered by artificial intelligence, and backed by Google. So now we get on to the fact-checking. And when we first traveled to San Francisco, and we had to grapple with what we wanted to do with the very unique opportunity we had with Google support, we very quickly identified that fact checkers around the world face 3 common problems. And those problems are figuring out what is the most important thing to fact check each day. Secondly, how can you increase the impact of your work? And thirdly, how can you know statistical claims are wrong in real time? With Google.org support, we spent the last 3 years focusing exclusively on these 3 challenges. To address the first problem, we really wanted to find a way that we could take a vast, varied, and increasingly complicated media landscape that fact checkers are monitoring on a daily basis and cut out everything which can't be fact checked and only show fact checkers claims which contain factual claims. If you work in fact checking, you will know that a sentence, a statement which can be fact checked is generally quite specific. You need a number or a measure of some sort. You generally need a time frame. You sometimes need a trend, whether things are increasing or decreasing. And those sentences can be far and few between. And if you have to manually read through newspapers, social media, press releases every day, fact checkers who have very rare and valuable skills are not able to spend their time doing what they do best, which is interrogating data, speaking to experts, writing up their results, and speaking about their work. So we really wanted to find a way to find claims efficiently in traditional media, social media, parliamentary records, video, and audio. And to that end, we have built a tool called Candidates, which does claim identification. To answer the second question, we wanted to be able to tell fact checkers when something that they know is wrong is repeated again so that they can take action. And this action can be taken in a number of different ways by different fact-checking organizations. And it's something that we'll explore a little bit later in this presentation. And lastly, we wanted to give fact checkers the opportunity and really the power to know in real time when claims about statistics are false. And the stats checking model, which we are currently working on and is in development at PhilFact, identifies statistical claims, breaks it down to their component parts, finds the relevant data, and then gives the user an indication of whether that claim is correct or false. So as I explained, in this first problem that we're trying to solve, that is, how do we find the most important thing to fact check on a daily basis? This is one of the interfaces of the tool that we have built, which is called Candidates. And when it comes to this tool, we are giving fact checkers the ability to add a variety of media that you are interested in. So at the moment, I'm in the process of onboarding a new fact checking organization who has provided extensive lists of the different RSS feeds and news websites that they are already monitoring, but would like to be much more efficient at monitoring. We add them to our tool. These RSS feeds are scraped on a daily basis, and then we have a claim identification algorithm that we trained with fact checkers, which is able to identify a sentence that contains a claim. And what that allows fact checkers to do is to claim back hours from their day of manually trawling through media of all types to find a needle in a haystack. We've slashed the haystack, we've taken out everything that they won't be interested in, and we're presenting only the sentences that are fact checkable. And this means that fact checkers have more time, they're more efficient, and importantly, they're able to make smarter decisions about what they fact check. And it's harder for politicians, public figures, influencers, the media to make false claims which go unnoticed because of the noise that is the media landscape. We're able to find sentences and help fact checkers find important statements that pose a risk to public health, understanding about the economy, and trust in government. So we have this tool being used at Full Fact. It's an integral part of our editorial team who uses it to identify claims in traditional media, as well as using it through CrowdTangle to identify posts and claims on Facebook, which we are then able to fact check. And Twitter is not exempt either. We're able to flag tweets by significant members of our societies in order to identify claims, interrogate them, and ultimately hold public figures accountable for what they say. So that's what the tool does, but what impact has it had? So Africa Check, where I previously used to work, has also been using this tool. And importantly, it was actually one of the organizations that was integral to building this tool. The grant which Full Fact won was actually due to a group of fact checkers, Full Fact, Africa Check in South Africa, Kenya, Nigeria, and Senegal, as well as Chequiata in Argentina, coming together to build a tool that really met the needs of fact checkers around the world. And at the end of 2021, there was an election that was conducted in South Africa, and Africa Check used the tool to identify factual claims in that election debate. And as a result, 25% of all the fact checks that were published in the last 6 months of 2021 were identified with Full Fact's AI tools. And that really saved hours of researchers having to read things manually, trawl through manifestos, trawl through tweets about elections, and really cut to the key issues that they needed to address to help the public understand if what political parties were telling them was true or false, and determine who could be trusted on key issues. Another example that I can share with you is, as some of you will be aware, Meta, who owns Facebook and Instagram, has a third-party fact-checking program, and that's what TPFC stands for in this slide. And what that program does is it allows verified signatories of the International Fact-Checking Network to join the program, and they are then paid by the platform to fact check and rate posts on Facebook. And if these posts are found to be false, the platform downranks them to reduce the spread of that false information and to ultimately reduce the negative impact that it can have. And in August this year, when we started really trialing the claim identification software, we were able to find that 10% of all of our third-party fact checks were identified by AI tools. And this was really the first month that we focused on this approach. And it was a very promising indication that our AI tools can't just help us combat and identify false information, but through programs like Meta's third-party fact-checking program, it can actually increase the revenue that fact-checking organizations are making to sustain the work that they are doing. And now I'm going to pass over to David, who's going to take you through the science and the tech behind everything that I've just shared with you.
Great, thank you very much, and good evening, everyone. It's a great pleasure and honour to be here speaking to you, to the AFCN and our age groups. And thank you, Kate, for that brilliant introduction to the technology we've been developing. As Kate said, I'm going to be talking now a bit more about how we developed the technology behind the first of those tools, basically how we can help fact checkers decide what claims they should be checking each day. And because I'm a scientist, the first part I want to do is to try to define more formally what a claim is. And so after some discussions with colleagues, we came up with this definition that a claim is a statement about the world that is either true or false. So we may not know whether a claim is true or false, but what we're trying to do is exclude claims which are, exclude statements which are not about the real world, so fictions or jokes, or statements which are not claims at all, like questions or instructions. There is. I am on the English channel. Yeah.
ديفيد فيك تكمل
Okay.
كمل تفضل.
So I was about to say, we came up with this definition of what a claim is. A claim is a statement about the world that is either true or false. I hope the audio is now working correctly. Okay, I'm going to carry on unless I'm told not to. So the purpose of this tool really is to identify claims made in the media or social media, and then to characterize the details of the claim, to identify what type of claim it is, so that we then help fact checkers to search over that list of claims to find claims that they're actually interested in checking. So once we've identified a claim, i.e. a statement about the world that's true or false, we can also identify who made the claim, who said it, who they're talking to, what was the audience, when did they say it, what did it refer to, what is the topic of the claim, and so on. And finally, of course, ultimately, whether it's true or false. And focusing really on what types of claims there are, one reason for approaching this part of the problem is to recognize that fact checkers basically, they can't check claims about the future. We don't know if it's, if I say next year inflation will fall, no one knows if that's true or false yet. It is true or false, but we don't know yet which one of those it is, so we can't check it yet. And similarly, if someone makes a claim about their own personal beliefs, we can't investigate that, we can't see inside their heads. So those types of claims we want to be able to identify and then set aside and ignore them, leaving behind claims which are more likely to be checkable. So for example, claims on official statistics, such as inflation or unemployment, are often much more straightforward to fact check. And so after some discussion with our fact checkers within Full Fact, we came up with a list of 10 categories of claim types that are useful for sort of characterizing claims. With this in mind, so we can then filter out claims we don't really want to check. And so what we wanted to do really then was to build a tool using AI to identify these types of claims in new media as they come through our systems every day, from newspapers and TV debates and social media. So before I get on to the technology we actually used, I thought it'd be useful to clarify some of the terminology that I'll be using. I'm sure a lot of this is familiar, but just make sure we're all agreed on the terminology. So AI, or artificial intelligence, has changed meaning a lot over the last few decades. It often, these days, it is used as a kind of marketing buzzword just to mean something new and clever. But really, it's any software, any technology which solves a problem that would normally be thought of as requiring human levels of intelligence. So it could be anything from playing a game of chess to anything involving conversations, language, planning, and so on. Machine learning is really a subset of AI that specifically refers to computers that are learning from training data, learning from examples, and learning to improve their own behavior. Machine learning often requires people to provide labels to the data first of all. I'll give some examples of that shortly. And thirdly, we have natural language processing, or NLP, which is basically anything where computers are being expected or being trained to process text, either as speech, sometimes usually written text. And again, as discipline's been around for many decades, but over the last 5 to 10 years, there's been a lot of improvement using statistical NLP, which uses machine learning to teach computers about how to process natural language. So come back to the problem we're facing, how to identify different types of claims being made in the media. We developed a tool based on another tool. So Google provides an open source language, a large language model, called BERT. What BERT is a statistical model of language that's been trained on literally millions or hundreds of millions of sentences in English and also multiple other languages, about 100 other languages. And it's been trained basically to recognize the order in which words appear in a sentence typically, and the order in which sentences tend to appear in articles. I can do that just by analyzing large amounts of text, mostly scraped from the internet and some self-published books. And this way it captures the statistical properties of language without too much human effort, just a lot of computing effort. And the great thing about BERT and other similar models is that you can download them for free, and then you can fine-tune them. You can tweak them to your particular requirements. So in our case, at Full Fact, we created a list of a few thousand sentences from UK media, and I asked my colleagues basically to go through these sentences and label each one and saying, is this claim, is a sentence a claim about someone's personal beliefs? Is it a quantitative claim about some public quantity? Is it a prediction about the future? And so on, going through the 10 different claim types we had earlier. That took a few weeks to gather the data. But then it takes literally a few seconds to train up this model, to fine-tune it. And when it's fine-tuned, we can then use it to label every sentence coming in. So now we collect sentences from the newspapers, from the parliamentary debates, and so on. And every single sentence, we can label it as being a personal belief, prediction, and so on. And then we can further enrich these sentences, these claims, using a variety of tools. Some of these are ones we developed in-house, some are relatively straightforward off-the-shelf tools. But inside you can see we have one tool which identifies the entities in a sentence. So for us, that really means identifying the people, places, and organizations mentioned in the claim. We also have a quotation detection system which recognizes the claimant, so who said this, who made this claim. And then thirdly, we also have a topic detector which recognizes the broad topics that a claim is about. So I want to give one word example. So in the UK, our Health Secretary, Dr. Therese Coffey, was giving a speech recently, and here's 2 sentences about it from a newspaper. And we really want to analyze the sentence in bold. The second one saying, she showed that 40% of the government's day-to-day public spending goes to health and social care. This is the type of thing that fact checkers, Full Fact, want to check. So what we do is take that sentence, and the algorithm goes through a series of stages to basically enrich the sentence, to add more data to the sentence. So going from left to right, we can see, first of all, it identifies the claim type using the BERT model I was just describing. And in this case, it picks out that this sentence, this claim, is a quantity type claim. It's about specifically 40% of government spending. And then come across here, we have the broad topic of the sentence, which is around both health and politics. We have another feature called co-reference resolution, which is a technical term within NLP, which is identifying when 2 or more words or phrases in a sentence actually refer to the same real world entity. So in this case, the word she in the second sentence matches up with the name, Dr. Therese Coffey, in the first sentence. So the system now knows that those 2 words refer to the same person. And finally, if we link that back to Wikipedia, or Wikidata, in fact, which gives us a unique identifier. So now we have other information around this person, Therese Coffey. So for example, we can look up now in a database and know that she is a Conservative Party spokesperson for health. And we can also find out that she's a real person, not fictional, that she's alive, and so on. So given all this information tagged onto each sentence in turn, we then go back to the candidates tool that Kate showed earlier, and this is the interface now filled in. So in this case, I searched for statements about inflation, which contain the claim type of quantity, and are statements made by the group of people labelled as conservatives, in this case, the government spokespeople from the UK. And this is found 6 claims, as you can see, they're made by Liz Truss, made by other government figures. And so with this approach, we can now replace the many thousands of claims that we process every day. So in full fact, we collect around 100,000 sentences every day from mainstream media and from social media. Using this tool, we can identify claims in around 72,000 of those sentences every day, which you can imagine are far too many for only one person to be reading. But if you further filter those down to just look at quantity claims and claims from an identified claimant, i.e. ones where we know the person who's actually been making the claim, you see the figures get much smaller. And when you start adding in particular topics or phrases that people are searching for, then the whole process of choosing which claims are worth checking becomes slightly more amenable. So at this point, we'll take a very short break, and we're happy to take any questions about anything we said so far. And then Kate will come back to talk more about claim matching and statistical claim verification, and then I'll give you the technologies of those. But first of all, are there any questions? I'll hand back over to Saja for the moment.
Thank you so much, David and Kate. Azza Mughazi is asking if you integrated into CrowdTangle.
Yes, it is. So FullFact has access to CrowdTangle, and we have been able to, over the years, craft a number of different lists of groups and pages where we have different categories and topics for different type of false information that we're monitoring to fact check. And the posts from Facebook and Instagram, which CrowdTangle allows us to access, are analyzed through this tool in the same way that any other text is. So we are able to, for example, every day provide our editorial team with a spreadsheet that we generate each morning with key posts that contain statistical claims, that also contain certain keywords that we're looking for, and certain markers that we believe make them more likely to be something that we want to fact check. So this can be the number of shares, the number of people who have commented on it. So it really is a key way that we're also able to sift through a lot of content on Facebook that we wouldn't be able to do manually. David, I don't know if you have anything to add from a technical side.
Just say yes. We, as Kate said, we have options to include text from CrowdTangle. We are quite flexible in how we can add in other text. So, for example, we also add in transcripts from radio and TV and YouTube videos, and in the past we've analysed election manifestos. So we're pretty flexible in the sources we can take, including CrowdTangle.
Okay, I think the tools are internal, but Azza is asking, is there a tutorial available on FullFact's website that we can use for training on the tool?
We don't have a tutorial available on the website. Currently, the tool is primarily and really only available in English. This is something that we're going to discuss later, and we're going to be working on expanding to new languages. We don't have a tutorial available on the website, but I am available to arrange meetings with different organizations, whether you're a media organization or a fact checker, to take you through in detail the tools, explain how we use them, give you a demo of some of it in action, so that we can show you what it's capable of. So hopefully in the future, when we do expand our language offerings, we may be able to work with some of the organizations.
Okay, Ola is asking exactly about the tool. Is it a website or like programming language or machine translation, and on what stage it can be used?
David?
Yes, so the tool's available as through the web browser. So there's no programming skills required at all. It's purely designed for journalists and fact checkers to use without any technical training. So the back end, the part I developed, yes, obviously has machine learning and AI in it. But it's yes, it lives entirely within the browser.
Okay, thank you. We have the same questions from Yusuf and Islam. The question is about how could AI overcome the misunderstanding that may resulting from different dialects of the same language, especially in a complex language like the Arabic language?
Yeah, it's an excellent question, and the short answer is I don't yet know. As Kate mentioned, actually later in the presentation, we'll be talking a bit more about plans for multilingual work. The hope is to introduce multiple languages, including Arabic, over the next year or two. To what extent we need to deal with different dialects of those languages is a good question. And I must confess here, I'm not an expert in Arabic at all, but my understanding is that there is the standard Arabic, which is used in most newspapers and government publications, I believe. So I think the first place would be to make sure that we can process that language most reliably. I will be using here existing tools which people are producing to work in different languages. So I'll need to investigate basically how well they can work on different dialects of languages. So yeah, that's something which we are aware of but haven't yet tackled.
Okay, so here we have a question from Imad and Abdulrahman. They are asking, are there any plans to create an Arabic version of this tool? If so, will it be paid service? So can we turn this tool to an Arabic language tool, David?
Yeah, basically, later on in the presentation, I'll be talking about our plans to make this work in Arabic. So currently not yet, currently it's English only. We've done some experiments with other European languages, and we're planning to make it fully available in Arabic and other languages in the future. Perhaps Kate can discuss the business side of that in terms of the pricing.
Okay, so we can continue the presentation now. Go ahead, thank you.
Okay, so it is back to me, and thank you so much for your questions. It is really important to us that although we're here to share the information that we have and what we've done, it's really important that we are meeting the needs of the fact-checking community, as well as making sure that we answer your questions so that you really get the most out of this. I am just attempting to move the slide forward, which is proving slightly difficult. There we go. Okay, so now we are coming to, in this section, an opportunity where we're going to get to speak to the second and third question that I posed at the beginning of this talk. And the second question was, how can we help fact checkers to increase the impact of their work? And I think this is a good place here to speak about some of the different types of fact checkers that we find around the world. So there is a term or terms that are used in the fact checking community, and those are first generation, second generation, and third generation fact checking. First generation fact checking refers to fact checking organizations which largely appear similar to traditional media or news organizations. Their main and sometimes only output is to publish work, to identify statements in the public domain, to do the work of fact checking, to publish the work, and to really put that correct information, that counter to the false information, out into the public domain, and to really let it do its own work. Let the public read it, let people engage with it. But for the most part, their work stops there. They counter false information by publishing correct information. We then have something called second generation fact checkers who do everything that first generation fact checkers do. They do the monitoring of the media, they identify claims, they do the fact checking, they publish their work, but then they actually try to change the system which allowed that false information to be created and shared. And they do this often through intervention work. So that is by interacting with systems, by intervening, by speaking with politicians, by requesting corrections, so that they can ultimately try and fix the system, the broken parts of the system, which allow this false information to be shared, as well as correcting false information. And now the concept of third generation fact checking is that You need to do everything in first generation, you need to do everything in second generation, but importantly, in order to fight the problem of false information, which is at internet scale, which moves at the speed of light, which is so vast that it's hard to quantify and to imagine in your head, you need to scale your efforts to internet scale. You need to use the power that David has been speaking about of artificial intelligence to really increase the strength, the speed, and the impact of your work so that actually fact checkers have a chance of combating the amount of false information that we see on a daily basis. And you can see here on your screen, this is our head of automated fact checking, Andy Dudfield, in San Francisco a couple of years ago. And he's really making the point that I'm going to be expanding on now. And that is that we have to make our fact checks work harder. We cannot put all of that effort, those resources, the hours of people doing the work, the money that we collect from donors into our work and publish one report, and then that's the end of it. There's a phrase that I like to use, is that we need to get more juice from every squeeze. And, you have a fact check, how much impact can you get out of that? How can you create more change in the world out of one fact check? And that's what we're looking to do with the second tool that we're going to share with you today. So what the second tool does that we have built is called Digest. And simply what it does is it is a claim matching tool. When you publish a fact check, and many fact checkers around the world use Google Claim Review to mark up their fact checks so that they can be surfaced in Google search results. We are able to use that claim review, or in instances where organizations don't have claim review, we're able to add the claims that were fact checked to the tool. And every day when we are scraping the media that we're monitoring and we're running our algorithms through all those sentences, not only are we in the first tool looking for claims that contain factual assertions to show our fact checkers, we're also comparing every sentence to every claim that we've fact checked. And what that allows us to do is it allows us to flag to our teams when a claim that we know is wrong, we have fact checked it, it is false. If that claim is repeated again, we will tell our team about it. And this is the interface that you're seeing here. On a daily basis, our editorial teams, our intervention teams, our automated fact-checking teams can go onto this platform and can review those claim matches. And what this really does is it unlocks a world of actions that previously fact checkers don't have access to. And I want to share just a few examples of how different organizations can use this tool to have a significant impact in their work, irrespective of whether they're first, second, or third generation fact checkers. So I can share 3 examples with you, and they really are 3 examples from the 3 fact-checking organizations that were integral to building these tools. So first of all, we have Full Fact. On a daily basis, our colleague Bethan, who does our intervention work, logs onto the platform, comes to this interface and reviews the claims which have been matched. And you can see here actually a claim which David spoke about earlier, and that is a claim about the amount of spending for health and social care and what percentage it is of day-to-day spending. We fact check this. We know that in a number of instances it has been false, and it's found another instance of this claim repeated on this day from Parliament's Hansard, so a record of everything that is said in Parliament. Here we have another claim about energy bills, and then you see actually a third claim again about the percentage of day-to-day spending when it comes to the health sector. Bethan's job, what she does every day, is to try and get people to correct the record, because key to our work is that we believe that people in powerful positions shouldn't spread false information, but when they do, they should correct the record. And it is an obligation and a responsibility of all people in public eye, but especially those in elected office, to publicly admit when they make a mistake and to correct any record of it. So this allows Bethan to contact more people, to inform them that they've shared a statistic that we've known to be false, so that we can get them to correct that error. There are also other things we can do if we notice a trend of this claim or any claim that is false being repeated more and more, or popping up, or there's a sort of flood of them at a certain point. We can think strategically about why it's happening. Do we need to do another fact check? Do we need some sort of pre-bunking resources? Should we write an opinion piece? Should we write to a regulator? Should we write to someone in Parliament to address this issue? So this is really integral for PhilFact to trying to fix what is a broken system. And what it does is it's an alarm bell. It sets off a red light and a siren every time a piece of bad information is shared again, so that we can respond appropriately. But not all organizations work as we do. So another example that I can give you is at Africa Check. And Africa Check also does some intervention work, but largely what Africa Check uses this tool for is to really feed into their editorial process. Africa Check has a publishing format called a spot check. So if they fact check a claim for the first time and it's false, they will usually write a long, in-depth piece which really interrogates and picks apart the issue. And that's anywhere from 800 to 1,200 words. But if that claim is repeated again by another politician, the media, it's often not necessary to go into all of that detail again. And we also know that shorter fact checks are much more accessible to people. So Africa Check uses this dashboard to identify when they can do a spot check. So they may be able to do a full-length report, and every couple of weeks when the claim is repeated, do another spot check, addressing the new person who's made the false claim, adding in a bit of new context. And it's in this way that this tool creates a feedback loop into the editorial team. And the analogy that I like to use is that if you're a gardener, you may understand this. If you work in a garden and you find a weed, you pull out the weed. But pulling out one weed is not going to stop the weed from appearing in your garden. Every time you see a new tip of that weed poking out of the soil, you need to pluck it. And if eventually you keep plucking those weeds, they will stop coming back. And that's what this tool allows you to do. It allows you to pluck the weeds of misinformation out of the media garden that you're working in, so that they stop growing back. And then lastly, the third example of how this tool is really so varied and can be used in different ways is an example from our colleagues at Chequeado, which is a fact-checking organization in Argentina. And they use this tool in a somewhat similar way to Africa Check, but they're not generally republishing. They're using it to feed and drive their social media. If they've published a fact check of a claim that they know to be false, and a tool which uses this capability informs them that it's been repeated, they're able then to feed that into their social media and communications team, so that they can then post a tweet, post a Facebook post saying, this claim has been made again by this person in this context. We fact checked it a month ago, read the full report here. And they're able to correct that false information, but also drive people back to accurate information, back to their website. And so you can see how this tool takes what could have just been one report published with one URL on a website one time that had one impact, and it really provides you the opportunity to scale the impact of this work to an infinite level. That fact check is going to keep working for you with this tool, and you're going to be able to reapply all of the energy that you invested to new instances of false information without any additional effort or very minimal additional effort. And it's in this way that PhilFact has been able to identify serious false claims that have been repeated many times by leading politicians in the United Kingdom. And the tools which I've just shown you have identified over the sort of since the beginning of this year, claims that have been repeated not just by former UK Prime Minister Boris Johnson, but also by other ministers who repeatedly and misleadingly claimed that there were more people in work in the UK than there were before the pandemic. And sidebar, I'll give you the fact check. While at the time there were more payrolled employees, the total number of people in paid work, including the self-employed, was below the level seen prior to the pandemic. And in each of these instances where we found a repeat of this claim, we were able to react almost immediately, contact people, publish a new fact check, intervene. And importantly, we were actually able to take action by writing to the United Kingdom's Office for Statistics Regulation in January of this year about the misuse of the data, including at least 5 separate times in Prime Minister's questions. And as a result of this tool, giving us this capability to identify all of these instances, we actually had the Director General for Regulation of the Office for Statistics, Ed Humphreys, write to the Prime Minister's office and tell him that it is incorrect to make that statement. And that is the type of impact that you can have when you have technology working for you, because it works while you're sleeping, it works while you're fact checking, and you're able to check in once a day and then use the information that it's provided to you to make significant actions that can have real impacts on the information landscapes where you work. So now we're going to, apologies, let me go back one. Now I'm going to speak to the third question that we identified when we came together with fact checkers from around the world to identify the problems that we needed to address. And the third question is, how can you know that statistical claims are wrong in real time? And as fact checkers, if you're in the audience this evening, or journalists, people who work in media, you know that a lot of the focus of fact checking and interrogation is on statistical claims. When people use numbers, they talk about rates, percentages, trend lines, GDP, inflation, employment. At the heart of those claims are statistics. And what stats checking allows us to do is offer users, fact checkers, journalists, a tool that informs them in real time if a statistical claim is correct or incorrect. And this has a significant impact on the work that fact checkers do. And the first thing it does is it solves one of the problems, which is that fact checkers can waste time verifying statistical claims. And that happens because if you have a statistical claim, and this is often in a live fact checking context where there is a speech being given, it might be a state of a nation, it could be a prime minister's questions, and someone shares a statistical claim. You want to publish something within an hour, you need to push it out, you look at this claim and you think, okay, we need to check if it's true or not. You go through the process and maybe 10 or 15 minutes later, you realize it's correct. And you think, we're not going to add anything to the debate here. We need to focus on correcting things that are false. And you've wasted 10 to 15 minutes at least, possibly more if it's a complex claim, verifying that something is correct and you're probably not going to work on it. So this allows fact checkers to prioritize claims that are false, because that is where we can add the most value in public debate, by informing the public when things they have been told are false, and by holding public figures accountable for sharing false statistics. Of course, we don't intend for fact checkers to solely rely on what you will see as an enrichment or a graph that is generated. It is really just a starting block, a step up in the process to get an indication with a link through to the original data so that you can verify the statistical fact check which has been done. And in this way, we're able to speed up the verification process, point fact checkers towards the most egregious misuse of statistics, and allow them to focus their efforts where they can make the most impact. So this tool is currently in development at Full Fact. We are using it in our live fact checking, and our intention is to ultimately roll this out to users globally where there is robust data when it comes to key issues. At the moment, we're looking at the issues of inflation and employment in the UK, and central to stats checking working is that you have access to data and that the data is of a reliable and high quality and quantity so that it can meet the demands of the stats checking algorithm. And now I'm going to hand
to David, Kate, let me just tell you this question from Malak and Sumaya are asking the same question about how do these tools assess and conclude that a claim is false?
Okay, so I think David is going to answer some of that in his presentation now. Is that correct, David?
Yes, sorry to unmute myself. Yes, I'll be talking now about how we do both claim matching and also the automated verifications. I'll try and answer the question as we go along. That's okay?
Yes, sure. Okay,
great. If I don't answer the question, then please do ask it again in a few minutes when I finish my next section. So what I now want to do is to describe the technology behind the digest tool that Kate mentioned, basically to determine, to answer this question really, have we checked this claim before? Can we make therefore best use of the claim we've already published? And again, to try to make these things slightly more rigorous and formal, we first of all wanted to work on a definition of what exactly do we mean by claim matching. And really what I mean is that two claims match if they say the same thing but using perhaps different words. So one is a paraphrase of the other. And the idea in particular is if one claim is a claim that we've already checked and published, and a second claim comes in from social media or from mainstream media, we want to know if those two claims are saying the same thing, but using different words. If so, then we can perhaps make more use of the spot check that Kate mentioned for Africa check, or to use an existing fact check article to sort of ask for a correction very rapidly. Another way of thinking about this is saying, if we know that one claim is true or false, then that tells you that the other claim is true or false. If that statement is true, then you know the two claims are saying the same thing. I'm not sure if that helps you or not, but it's different when I think about the same problem. And a third way of defining it really is saying, can we actually reuse the same fact check article in response to both claims? Or again, if we've already checked it once, can we use the same article in response to a new claim coming in? If so, then we say that this is a matching claim. As what we're trying to do now is to develop a tool which can automatically find all of these matching claims, all the claims in the media which match claims that we've already fact-checked. I worked on this tool for quite a while, basically most of last year, and it is a hard problem for several reasons. One is that language, spoken or written, is always ambiguous. Every word has multiple meanings, every sentence has many, many meanings. And so deciding whether two claims mean the same thing is pretty hard for people to do. And people are really good at using language. We've been using language for hundreds of thousands of years. We use it through our entire lives. Computers, relatively speaking, not very good at processing language. And so trying to decide whether two ambiguous statements are actually saying fundamentally the same thing or not is just intrinsically hard. Often to decide whether two sentences are saying the same thing, whether there is a match there, also often requires common sense knowledge, and requires knowledge about the real world. Again, something that we do ourselves as humans without really thinking about it, but computers struggle because they don't have that kind of context. And context itself is often missing from claims that are made. Indeed, many fact check articles do say this claim is perhaps true, but missing important context. If the context is missing from the article, it can be even harder to work out if a new claim is repeating the same misinformation. And the last reason why it's a difficult problem is that matches are relatively rare. I'll give you some examples in a moment, but it means just learning how to find them is hard because there are so few examples to learn from. So to clarify, the goal of claim matching, as we have formulated it within Full Fact, is to take every sentence in the media, newspapers, mainstream media, parliamentary debates, and so on, every sentence in the media, and every fact check that we've recently published, and determine one of each, whether they actually are equivalent. To take each sentence and each fact check, are these the same? And go to the next one. And to give an idea of the scale, if you're taking 100,000, if you're collecting 100,000 sentences per day from the media, and if we want to check each of those against the most recent 100 fact checks, that'll be published over the last couple of months. That gives us 10 million comparisons, just 100 times 100,000. So it's a lot of effort for the computer to go through. Thankfully, computers are very good at just churning out applying the same algorithm over and over again. But it's a lot of data to process. But it's worth bearing in mind that even just finding a few of these claims in a day can have a huge impact. That's how my colleagues, Beth and Kay mentioned, can reach out to politicians and journalists and say, you're saying something which we already know is false. Please, can you retract that? Please, can you correct that? So how do we actually do this? How do we build the tools to do the claim matching? As I said, this is quite a large long-term project we worked on. And the first part of this, the first attempt really, was just to use keyword searching. So for every claim we published, we'd identify a series of keywords associated with that, which we could then use basically very similar to, we'd use it in the same way that you would use a search engine just to look for matching phrases in other documents. Here we're looking for the same phrases appearing in newspaper articles, for example. And this works very well if there is a very distinctive phrase or value in a sentence. So an example we looked at earlier about 40% of government spending being on healthcare. You can imagine, searching for 40% and healthcare, perhaps you'll get a few positive matches. But for some claims which have much more generic common terms, this will produce nothing but false positives. So the next step we introduced was to use a different version of the BERT tool I mentioned earlier, this version called Sentence BERT, which again is a public tool anyone can use, which takes a pair of sentences and works out if they mean the same thing. It tries to extract some representation of the semantic meaning underlying a sentence and says, are they the same or not? This is much better at handling synonyms that the direct keyword searching wouldn't match. One problem is that the way BERT is trained is I mentioned earlier, it knows it knows the order in which words appear in a sentence. But the way it's trained is often to replace one word with another, see if it still makes sense. So for example, if it saw the word, the sentence, the dog is black, you might see a second sentence which says the dog is brown, and then learns that the words black and brown are in some senses interchangeable, which is great, it's very useful semantically. But in our case, it confuses similar entities. So for example, it thinks all numbers are basically the same, because in a sentence, anywhere where you use number 3, you could just as well use number 4 and to make grammatical sense. Similarly, names of politicians also turns out to be interchangeable. So we'd have a sentence like Boris Johnson claimed unemployment is falling, and a different sentence saying Emmanuel Macron claims unemployment is falling. And the BERT model will say, oh, these are saying the same thing, because actually they're different people and therefore they're talking to all different countries, different economies, and therefore not the same thing at all. So BERT helps a lot, but it doesn't solve the problem entirely. So then we introduced an entity matching stage. So this explicitly recognizes the names of people and places and organizations mentioned in both the fact-checked claim and also the media claim. And says, is there an overlap there? Are they talking about the same people? And so this does reduce some of the errors that BERT was failing, found the process correctly. So having introduced these 3 different methods and done some experiments with them, we then realized that basically they all have their own strengths, but none of them work perfectly by themselves. So the sort of final stage was to combine these 3 different measures of similarity into a single model. So now we use a new, quite small machine learning model, a neural network, and trained it up to predict whether or not the claim you see in the media is repeating the claim we've already checked. So this is an overview of the model. So at the top, we start off with the claim from the media, from newspapers, and the claim we've already checked. And we want to combine those together and measure 3 different measures of similarity. So there's the semantic similarity from the BERT model. Are these sentences meaning the same kind of thing? Do they talk about the same entities? Are they about the same people, places, organizations, and numbers? And also the search similarity. Would the same search terms return both media claim and the fact-checked claim? And take those 3 measures of similarity, and then we train a model to do the final stage prediction of are these actually matching or not. Now, to train up this model, this then becomes a sort of fairly standard machine learning problem. But as I mentioned in the outset, it often requires training data. So we then wanted to get a list of examples of pairs of sentences which were and were not matching claims. We want to get lots of examples where there was a match and many more where there's not a match, so the machines, the algorithms, can then learn to distinguish those two cases. This is one advantage when it comes to working for a charity, in that we have lots of supporters who want to help us in our work, and some of these people are very generous with their time, and so we asked them to actually help us annotate some data. And we produced a tool which looked a bit like this, where we could just show our supporters a pair of sentences here, claim A and claim B, which would be different sentences taken from different newspapers. And the simple question was, are these two claims basically saying the same thing or not? The answer is just click yes or click no. So it's quite a straightforward task, and really relies on the human intelligence of being able to understand a sentence quite quickly and see, are these two things saying the same thing or not? It doesn't require fact checking, it doesn't require to know whether either claim is true or false, which would be quite a different effort. It's just saying, do they mean the same thing? And so we collected tens of thousands of examples of these over several months, and use that to train up a model to combine the three existing measures of similarity. And then result, thankfully, was a working model, which Kay's already showed you. It's a slightly older version of Digest, but again, it shows you a series of claims that have been published, and under each one, it shows a series of media sentences that the algorithms I've just been describing think are matches. And while it's not perfect, it does produce enough useful data that can then guide either further fact checking, or it can guide our corrections work more directly. So the last tool we can talk about today is the automated verification tool. Excuse me. So this is, in some ways, it's perhaps the ultimate goal of fact checking in some ways, is to say, is this claim true or false? And Kate mentioned earlier that for statistical claims, this can involve some digging around through public databases and spreadsheets. And often the answer is yes, it is true, in which case there's nothing more the fact checker can do. The goal here is to see where we can do this work automatically, just to save a bit of time. So the outline, the dream, if you like, is to take media, newspaper sentences, or some social media, and take in the sort of official data from any government source or any official source, or including multinational sources of data, and then using some kind of cute AI to combine these two together and say, is the claim we found in the media true or false? Does it agree with the data, or does it contradict the data that's been published from the official sources? So the version of the full fact stats checker that's still under development, we basically take UK sources of media, so newspapers, the Hansard parliamentary record, and some UK parts of Facebook and Twitter. We then train up another BERT model. I've mentioned BERT a few times already. It is a very valuable tool for us to use. We use a slightly different version of BERT to identify the information within each sentence, within each claim, so that it can use its knowledge of linguistics to extract the key parts of a sentence. What is the topic? What is the date? And so on. And then once we've extracted the information, we can then compare that to the official figures produced by the UK's Office of National Statistics. So this is an example sentence from earlier this year. Inflation reached 5.4% in December. And the idea is that there are certain key phrases there we want to identify. And then we train up the BERT model to recognize that in this particular sentence, the model needs to recognize that inflation is the topic of the sentence. That's the statistic that we're actually talking about. Also, it needs to recognize that 5.4% is a number. And also, more importantly, perhaps, that number actually relates to inflation. Because sometimes the number could be referring to some other part of the sentence. In this sentence, we're talking also about the price of shopping and fuel and energy, but 5.4% explicitly links back to inflation. That's just a matter of the grammatical structure of the sentence that the BERT model can interpret. And similarly, it recognizes that the month December refers back to inflation and not to the rest of the sentence. So that's the kind of linguistic analysis that the BERT model can do. We're just giving you a few examples of this is the topic, this is the number, and so on. And it learns how to extract that information from the sentences, based very heavily on its pre-training, having been shown millions of sentences by Google. And then the second part of the stats checker is to capture the business logic, if you like, which you do by directly programming this in Python. And then we can encode information, things like inflation by default means CPI, consumer price inflation. So there are 3 different measures of inflation in the UK. It's amazing things you can become an expert in when you try to teach a computer. But we can recognize that CPI is the kind of the default measure of inflation. Furthermore, we can program that, we can teach it or show it that the definitive measure of CPI is at this particular URL. This is on the government website. So if you go to that page, you'll find a spreadsheet, and that's where all the current inflation figures are. We can also code out the fact that in this context, December refers to December last year, not 10 years ago or next year, just from the context of the sentence. And therefore, the consumer price index value for December 2021 is what the claim is about. And the claim is saying that's 5.4%. So then it becomes quite straightforward for the algorithms just to go to that URL, find the right number in the right spreadsheet, and see, is it 5.4% or not? Is the claim true or false? So this is work in progress, but in fact, it does often work very well. And here are a few examples of it working. These are examples from inflation and unemployment. So the first 2 examples are just 3 newspaper sentences talking about recent figures from inflation and unemployment. And the output to the algorithm just says, not just true or false, in this case true, but also it explains how it's made that decision. So it's saying, this is the CPI figure, or this is the RPI inflation figure. And in the full version, it also gives you a link to the database and a nice little graph showing you the current trends. And so if you want to verify, you can just click straight through and you'll be shown the official figures for direct comparison. So it tells you straight away if the claim is true or false, and also lets you interrogate that very quickly. Rather than spending 10 minutes trying to find out the true values, it'll just show you straight away. The last one's quite nice. The bottom example on the screen was from a newspaper article which claimed that CPI measure of inflation hit 6.7% in April. This is just false. I'm not quite sure why this happened. This is a newspaper in the UK. My guessing is that it was a editing mistake, or possibly just a typo from the journalist. But either way, it was a small mistake in a otherwise perfectly fine article. But the algorithms can straight away say, this is false, and here are the 3 measures of inflation for April 2022. And none of them are 6.7%. So the fact checker can look at this straight away and say, oh, yeah, okay, this is wrong. And then they can decide what actions to take next. Is it worth writing a fact check article, for example? As I mentioned, this is still a work in progress, and here are some examples of it not working correctly. So in the first example, this is a journalist explaining what inflation is as an explainer to the audience. So he's mentioning, hypothetically, if inflation was 2%, this shows how the prices would be changing. The algorithm thinks it's claiming that inflation is 2%, and therefore is wrong. So we need to teach us how to recognize hypothetical examples as distinct from actual claims about the current rate of inflation, for example. The middle example there, policymakers at the Bank of England, have raised interest rates to 1%, and later on mentions inflation in the same sentence. And the algorithm doesn't yet realize that 1% in this case refers to interest rates and not to inflation. So it's not claiming inflation is 1%. So the algorithm needs to be taught more carefully with more examples to distinguish between different parts of a sentence. And the last example is a common problem that the UK media does often quote things from other countries, not entirely inward-looking. And so in this case, it's quoted in the figures for inflation from Australia. And so Albanese being the Australian Prime Minister. And so again, the algorithm needs to be taught that it should be ignoring data from other countries, because we can't currently check that. So the current tool is focusing on inflation and unemployment. And every day it does find around 20 to 100 claims that labels as being true. And those are mostly correct. It does correctly identify those true claims. And this would save fact checkers time. It also finds a few examples every day which it thinks are false. And these are mostly examples I just gave where the algorithm has made mistakes around the country or the nature of the claim being made. And we're currently trying to reduce those false positives so the tool becomes more reliable and more useful. But it's great to be working on this tool, and we hope soon it'll become reliable enough to actually generally save fact checkers time every day in not wasting time verifying very straightforward claims. So at this point, I'll take another short break and take any more questions you have about this current part of the talk. And then after that Q&A session, we'll come back to talk about future plans, including making these tools multilingual. But thank you for now. Any questions?
Yes, David and Kate, we have a lot of questions. So Najib has some concerns on the technique. He is asking, have you considered possible unfair predictions that could arise for some reasons? And have you assessed the robustness of the trained models against adversarial manipulation of claims that could fool the models? And Yusuf is asking, is there a margin of error in such a software? What is the percentage?
Okay, to answer some questions, we haven't directly considered adversarial input because our primary focus is looking at claims being made in newspapers or in parliamentary debates. And at least for now, I don't think anybody's going to write an article deliberately to try to bypass our algorithms. If it does happen one day, that'd be very flattering in some ways. So currently, because it's not being used directly by people typing inquiries, I don't think it's such an issue. But it's something we should be we should be aware of. In terms of making it more robust, I think you said, yeah, we are trying to make the reduced number of false positive claims that it checks, so the tool does become more useful. So what was the other part of the question?
The margin of error.
Yeah, so again, at the moment, this tool only works in English. We have recently been collecting data from other countries, I think South Africa, Japan, and India from memory. Basically, wherever data is data on things like inflation and unemployment are being shared, we should be able to get the data in quite straightforwardly. The advantage using the BERT model I've been describing is that I don't need to understand the language the system works in, for example, as a developer. All I need to do is give some examples in the language. So far, that's been in English, but at least in theory, there's no reason why this shouldn't work in Arabic in other languages. It just needs some annotated sentences to pick out what is the topic, what is the number, what is the date, and so on. But this is again future work.
Okay, so Najib is asking, how about claims contradiction on time and on past? Is there an automatic way to tackle this issue, or a human expert is needed for such an issue?
So these tools are designed to be used by humans. So the output of the claim verification tool is only ever going to be a prompt shown to human fact checker. I think this one's true. I think this one's false. And so it always requires, I think it always will require a human fact checker to look at it in detail and say, given a wider context, given the audience, given the data publication, and so on, they can decide, is it actually a genuine piece of misinformation that needs to be corrected, or is it just some minor slip, or is it something which happened a long time ago, it isn't worth taking the action on? So yeah, there always will be a human in the loop to make that final decision.
Okay, I think this question is for you, Kate. They are asking about if the machine makes a mistake, how are you going to correct and to apologize to the audience?
So I think this relates just to what David has said. Central to the work that we have done on this is that we believe that fact checkers, people, are the most important part of the fact-checking process. There are some organizations out there who have built tools that are public-facing that automate fact-checking or verification to the public without having a fact-checker or a person confirming or verifying that the output is correct. We never intend for an automated fact check, such as the statistical checking that you've seen here, to be a direct link to the public. And that's for a few reasons. One, we want these tools to support fact checkers. They won't replace fact checkers. As you've heard David speak about, language is complex and nuanced, and there can be many meanings or interpretations for a sentence. And we want these tools to assist fact checkers to help them make smarter decisions and make them more efficient. So When it comes to making errors, no fact checkers are immune to making and publishing errors. And as a signatory to the International Fact-Checking Network, Full Fact, as well as all other signatories, are committed to open and honest corrections. So when we make mistakes, which we occasionally do, we admit our mistake, we correct it, and then we publicize that information so that we can ensure that anyone who saw the false information has a chance to see the corrected information. And I actually have a slide coming up where I show you, even when there is an error in the stats checking, or it doesn't get it quite right, it's not automatically linked to the public. And despite the error, it actually still provides useful information.
Okay, Islam is asking, some of fact-checking platforms don't use claim review in their websites. Is claim review essential for claim matching? And could you please give a little brief about claim review?
Okay, so yes, that is correct. Not all fact-checking organizations use claim review. For those that aren't aware what claim review is, it is a way of marking up or annotating a fact check so that it can be read by Google and surfaced in search results and as an enrichment. So when you mark up claim review on a fact check, you say what the claim is, who made it, the date, your rating, if it's true or false. You have a link to the URL. So if someone in the UK, for example, searches on Google, will energy bills be capped at £2,500? One of the first results which is brought to the top and highlighted will be a fact check by Full Fact, where it will say fact check, it will have the claim, it will have the verdict, it will say no, this is incorrect. Bills, that £2,500 is the average price a typical house will pay, but bills will be dependent on usage. So in that way, Google is able to feature and prioritize fact checks and accurate information to its users. Not all fact checkers use claim review, but that's not an insurmountable challenge for us. We are actually also offering this tool to a number of good information users. So we're looking at working with statistical regulators, national statistic offices to help them use our tools to identify when claims about their statistics that they publish that they know to be wrong are published and spread again so that they can take action to intervene and to correct misunderstandings in public. And that's often a mandate that those organizations have. So they need assistance to actually fulfill that mandate. We are able to add claims manually. So if claim review isn't an option for your organization, there is a way that we can work around to add claims manually to the interface so that we can still proceed in finding claim matches in the media that you're interested in monitoring.
سمية تسأل كيف تقوم الأداة بالتحقق من البيانات الرسمية، خاصة وأن انتشارها يكون كبير سواء على المواقع الإخبارية أو حتى تنقل تلك الأخبار على المواقع مثل الوضع في مصر على سبيل المثال. كيف أتحقق أو كيف تعمل الأداة خاصة إذا كانت صادرة من مصادر رسمية؟
I'm not sure if I understand the question exactly. We have hopes and plans that some of the functionality for these tools could be used by media organizations in live and breaking news events. Again, we don't intend for it to be public facing, but what we could do is if there was a newsroom, a radio anchor or a television anchor interviewing a politician who made a claim, we have a transcription service, that I'll talk about shortly, where the producer who is in the anchor's ear could have the tool up, they could have a live transcription, and there will be a flag or an enrichment where something that they've said has been fact-checked as false, and they can feed that information to an anchor to challenge that person live on air. And that is really what is missing sometimes with fact-checking, is that the counter, the challenge can be delayed. But I think the second part that the question raises is maybe to do with how do you fact-check official bodies who are releasing statistics? and how do these tools work in that regard? And I think that speaks to a broader challenge when it comes to fact-checking. Many fact-checking organizations have fact-checked governments, national statistics agencies, the World Bank, the UN, and found that their claims are false and that sometimes their statistics are flawed. And with all fact-checking, you have to interrogate the data, you have to share limitations, you have to triangulate to compare it to other data sources as well as get expert comment. And unfortunately, if you do have low quality data that isn't considered trustworthy, it is going to make your job harder. And that's why when it comes to stat checking, one of the limitations for the tool is that it is going to work best and probably only work in countries where there is robust statistical data, where there is trust in its quality.
شكرا كيت. ديفيد، لدينا الكثير من الأسئلة حول اللغة العربية وأن هذه الأدوات لا تدعم اللغة العربية، وعن نقص البيانات باللغة العربية مما يصعب عملية استخدام الذكاء الاصطناعي في العالم العربي. أظن أنك ستتحدث عن ذلك خلال البرزنتيشن، فتفضل يمكن أن نكمل ونعود للأسئلة لاحقا.
Yes. Kate, you okay to carry on?
Yeah, let's carry on. Okay. Okay, so what I want to share with you now is a screen grab, a video of an example of where you can see all of these tools coming together. So one of the things that we've mentioned a couple times now is live fact checking. And this is where there's an event, Prime Minister's questions, a State of the Nation address, maybe a debate between two election candidates. And fact checkers are fact checking that in live time, which means that they're listening to it or they're watching a live feed of the speech or the presentation. And as quickly as possible, they're trying to identify the claims that are made, fact check them and publish the work so that they can address falsehoods or misrepresentations as quickly as possible. This has two important outcomes. One, it will make politicians think twice about sharing false information if they know that fact checkers are listening and challenging them almost immediately on their false claims. But two, it also reduces the impact of their false statements because we're able to get accurate information out almost alongside the false information so that the public has a chance of actually being informed correctly on this topic. So we have functionality at PhilFact that we also are looking to include in our tool offering to other organizations, where we're able to use transcripts from a number of different sources, which I will cover later, to get a live transcript and run it through these three different tools. So just to recap, we're going to have a transcript. It's going to identify factual claims and highlight those for the users so they can focus on what is fact checkable and ignore what is not. It's going to inform the user if there is a claim that they have fact checked before that they know is false, that they can decide what action to take on. And thirdly, it's going to tell users if there's a statistical claim and whether it's supported by data or not. And again, it will allow them to make a decision about how they want to proceed. So I'm hoping that if I press this button, which I just did, you will see here, this is a demo where there is a live transcript that is being fed into this tool. Those sentences are being loaded as they are being made live, and the tool is transcribing them. And then what will happen is that they will be marked up as different types of claims so that users, which are the fact checkers, can then focus on the claims that they would like to fact check. What users will then see, for example, sorry, let me move this on, is this. So this is a screen grab of a live fact check that our editorial team did a number of weeks ago. And you can see here the transcript, which has been pulled into the tool, you can see on the left here that there are labels which have identified and labeled the different sentences as being different types of claims. And there's a filtering function in this tool which allows you to just view the claims. So for example, it would cut out these last two sentences so that fact checkers can just review the sentences that may contain something they want to fact check. But importantly here, what we have is we have a claim match. So in this live event, someone said that Keir Starmer, who is the leader of the opposition in the UK, the Labour Party, voted 48 times to overturn the will of the British people and take us back to the European Union. And you can see here that in real time, this is analysed by our claim matching algorithm, and it has found a match. And it tells the user this is not correct. It says that the figure appears to be based on how Mr. Starmer voted in 48 votes related to Brexit. But some of those votes were not about whether Britain should be part of the EU. So here you have immediate context and information for a fact checker. They can decide to tweet, they can decide to write a letter to the person who made this claim, they can decide to publish a new fact check. And importantly, they have a link here to the fact check. So they don't even have to undertake the time and effort that it would require to find it. They can open immediately in a window and use that as content for whatever action they are going to take. Now we have the example of stats checking. And here we have a claim that the rate of consumer price index inflation fell to 9% in April. So we generate a graph for the user. And what you can see here is that it says the verdict is true. And David may be able to go into more detail in this, but what you can see here is it's saying that the rate of CPI inflation is 9% in April. And when you look at the graph, that is correct. But the part that it hasn't quite been able to grapple with is that the claim is that it fell, because we can see from the graph that it's increased. And this is an example of when our tool, which is still in development, gets something wrong. But this content, this graph, this finding or conclusion isn't a live feed to the public. It's informing a fact checker who has the necessary skill and experience to look at this graph and say, something went wrong here, but there's still a lot of important information here that the fact checker can use. They can see that, yes, inflation was 9% in April, so that part of the claim is correct. It didn't fall though. And importantly, you can see here at the bottom of the enrichment, there is actually a link to the official data source for the Office for National Statistics in the United Kingdom. So the fact checker can click straight through to that data. They don't need to search for it. They don't need to have it bookmarked, and they're able to double check for themselves and also link to that in their fact check. All of this saves time, points checkers to the most fact checkers to the most important things to fact check, and gives them the resources that they need to do their job. A challenge that we encounter is how to get transcriptions from live events. And there are a number of ways that we do this. And I think another challenge that we face when it comes to providing these tools in different languages is that a lot of the transcription services which are available were designed and operate best in English. And that is a huge shortcoming and an issue which really needs to be addressed so that when it comes to transcription services, they are accurate and meet the demands of different users, but also so that users like ourselves who are trying to use them to produce tools for fact checkers are able to produce a high quality product. So when it comes to the transcription that we do in English, we have a number of different ways of doing it. The transcription that you're seeing here was done using Assembly AI, which is a AI transcription service that anyone can use online. You can buy credits. This was done very simply, but quite effectively. We had someone in the evening when there was a live event playing the live event on their laptop with the audio on. We had another laptop opposite it running the transcription service. And then we fed that into our tool and we were then able to enrich it. It's not sophisticated, but it works. And it especially works when you have a unique event that you need to transcribe into a tool and you don't have the time or the resources to build an ad hoc solution to get a transcription. And you can see here that there's a lot of sentence splitting, and that's because of the way that people speak. As you can hear me talking now, we pause, we take breaks, we emphasize sentences, and as a result, there's a lot more sentence splitting. In comparison, you can have a look at this transcript, which comes from Prime Minister's questions in the United Kingdom. And in the previous slide, this is done by an AI transcription service, and there are a number of errors. I think because of the service as well as the method that we were capturing the audio with. But in comparison, these subtitles from Prime Minister's questions on the BBC are actually captured and transcribed by people by hand. There are people who are live typing and transcribing. And as a result, there's less sentence splitting because they capture the block of text that a person speaks and they keep it together. And there are generally less errors because people are listening to people talking and they understand the context. And so we have a very high quality level of transcription here. And what this really highlights is that there are lots of moving parts to the problems that we're trying to solve, and that being able to capture live audio, transcribe it, and get it into a tool, the quality of that transcription is going to have a significant impact on the quality of the output from these automated fact-checking tools. And when it comes to doing this in other languages, that's going to be an area that we're going to have to invest a lot of time and energy trying to understand how we can provide a high level of output for users around the world. And then lastly, we're looking forward for the next 3 years. We were very happy to announce earlier this year that based on the success and the impact that we've had so far, Google has decided to invest in our program for another 3 years so that we can radically scale our offering. So this means more funding, which allows us to expand our automated fact-checking team by hiring an additional 2 data scientists, as well as another software engineer, so that we really can be at the cutting edge of automated fact-checking and be innovating at a level that means that we're moving the whole fact-checking community forward. Secondly, we're looking to radically scale our number of users. Over the past few years, we've had maybe a handful of users, around 5 at any time in different sectors. We are looking to make this an offering that at a very affordable rate is a paid for service. In order for our work to be sustainable, we need to be able to fund our team, fund the development and the cost of a lot of the work that we do. So we are looking to offer our tools at an affordable rate to fact checkers and other users around the world so that organizations that don't have any tech experience, don't have in-house development teams or data scientists can still use and implement cutting edge AI technology to increase the efficiency and impact of their work. And if you're interested in having a discussion about that in the future, when we're looking at doing an Arabic offering, I'd be very interested to talk. And then lastly, along with more users comes more languages. And of particular interest to us is ensuring that these tools not only serve English language fact checkers, but also serve the wide variety of fact checkers around the world. And importantly, we're looking to invest and provide these tools to fact checkers in languages which have historically and currently are underserved when it comes to technology of this kind. We're looking to have a lasting impact on the fact checking community. And Part of that is working with fact-checking organizations to ensure that the tools that we're building meet their needs and their very unique circumstances when it comes to their countries, their media environment, and their languages. So now I'm going to hand back to David for him to chat about what this means technically for the next 3 years.
Great, yes, thank you very much. And yes, to continue straight on with that point, I want to talk a bit now about non-English language versions of this tool and how we're planning to build them. So first, a bit of context. Historically, natural language processing, getting computers to process language, has been driven almost entirely by the English language work. Principally, this comes out of America. Americans spent a lot of time and money developing these tools going back to the 1950s, really. Efforts during the Cold War, basically, to get Americans able to translate Russian text into English for their own analysis. And so IBM did a lot of work in the 50s, and big universities, Silicon Valley and so on, have built on this and tried to make their tools more powerful and more capable of processing text, but that has almost exclusively been English. And this dominance of English can become self-perpetuating. Most of the work we've done at Full Fact is building on existing tools, because starting from scratch just takes far too long. And therefore it's much easier to start with English language tools and then make those bigger and better. And a lot of these algorithms do require training data. There's another form of bias, is that things like the BERT model I've mentioned a few times, this is trained by collecting lots of data, usually from the internet, because that's easy to get hold of, digital copies of web pages and documents. And it's hard to measure, but according to one estimate, I quote here on the screen, something like 60% of websites on the whole internet are in English. It is the dominant language. I'm sure this won't surprise any of you. According to the same study, I think Arabic was ranked the 12th most popular language on the internet. About 1% of websites are at least partly in Arabic. So you can imagine if you start off by just collecting random bits of text from the internet in order to train your model will be very good at English and kind of okay at maybe Russian and Spanish and less good at many other languages. And given that there are about 7,000 languages spoken in the world, many of those have very few resources available for these kind of technologies. And as a real issue, we want to make these tools available to people in other languages so they can do fact checking and do journalism in their own language. It's really important we do this. And so we're now looking at tools with Google's funding to make this available in other languages. So one sort of straightforward option perhaps is to look at machine translation, getting computers algorithmically to translate from one language to another. As I hinted at earlier, a lot of the early work here was done translating work. A lot of the early work was done in translating Russian texts into English during the Cold War, which didn't really work very well at all, despite a lot of effort. But newer tools developed over the last 10 years or so have got a much more accurate output. I'm sure we're all familiar with using, almost without thinking about it, little translate buttons in places like Twitter. It's fantastic right now to have a translator translating my words into Arabic for you. I still find that human translation almost miraculous. Getting algorithms to do that, even to a sort of 80% accuracy, does make communication much easier. And so one option we're looking at technically is, can we just take newspapers or speeches from languages like Arabic or Russian or Spanish and translate those into English, and then use our English language tools to process them? And this may work, but one likely issue is that the errors will be far from perfect, and that putting that erroneous, badly transcribed, badly translated text into the systems are likely to sort of compound those errors to make them worse. So an imperfect translation will then be followed by imperfect AI, and the output sent back to the original users will perhaps be less reliable. So we're also exploring ways to work more directly in other non-English languages. And so the BERT model and other models like that, in many cases, have been trained in multiple languages. So when Google released the BERT model, which is only 4 years ago now, one of the versions they produced was trained on 100 languages, basically the languages with the 100 biggest Wikipedia translations. So yes, English is still there, but so are another 100 languages. Just earlier this year, a few months ago now, a new open source consortium put together a new model called Bloom, which is interesting because it's trained on, particularly on low resource languages. So these languages which have far less digital resources than English or even Russian or Spanish. So this includes lots of languages from sub-Saharan Africa and from India, although English is still the dominant language even in this model. But what's good about these multilingual models is that they've been trained to process text in multiple languages without necessarily caring which language they're actually looking at any one time. The workings of the model are kind of slightly language agnostic. And what this means is, and this still feels like magic, even though I've seen it happen, you can take these models, you can fine tune them, you can make them solve your particular problem in one language. And with no extra effort, they'll also get better at solving that problems in other languages straight away. This is because the inner workings of the model are sort of, like I said, language ambiguous. So long as the output is trained to solve the task you're interested in, claim type detection, claim matching, or whatever the problem happens to be, by improving to one language, you get, for no extra cost, improvements in other languages too. This is known technically as zero-shot cross-lingual transfer learning. So zero shots meaning no training data is required in the target language, literally none. Cross-lingual because going between languages, and transfer learning because we're taking one task and applying it to something different. So what this means in practice, and this is the kind of research I'll be leading at full fact over the next 3 to 6 months as you start moving into this area, is hypothetically, let's say for Arabic, although this applies to other languages too, but for Arabic, we could either train up a model in Arabic for doing claim matching in Arabic or claim detection in Arabic, in which case we need to get data. We need to provide Arabic speakers with lists of sentences and then get those to annotate them to say, yes, this claim is a personal claim, or these two sentences in Arabic mean the same thing. And so we could train up then a model. This requires a lot of effort, a lot of training for each language we want to move into. And even if we wanted to train a multilingual model in Arabic, again, we still need the same data set. The alternative is to start off with a multilingual model which knows English and Arabic, let's say. We already have the English language training data because we already generated this internally for things like claim detection, claim matching, and some of the claim verification work. And the hope is that by using that data in English, the models themselves will actually get better in Arabic and in other languages too. So by teaching this multilingual model to perform a particular task in English, it can also be able to perform a task to some extent in Arabic and other languages. In fact, in up to 100 other languages, if you're using the BERT's multilingual model. Now, it's likely that we need to further refine this. I don't think the quality would be good enough to work quite directly, but it does mean that even with a very small amount of extra annotations in the target languages, we have to be able to improve the performance in those languages up to a level where it will actually become usable and useful to the fact checkers. So like I said, this is just the start of a 3-year project, but we are very keen to be talking to people in other in our countries how we can develop these tools to help them work in their own language to the highest performance. I think just to conclude, we have some sort of suggestions. I hope you've been enthused, excited by this work on automated fact checking that we've been describing. And I think if you want to start these projects yourselves, I commend you, and I wish you good luck. I think it's a very exciting area to work in. There are some questions we would suggest you perhaps need to think about as you get into this. And I think I'll let Kate take over and talk about some of these questions.
Yeah. So I think what I would start with is, a lot of the time when you talk to fact-checking organizations about automated fact-checking and AI, organizations think that it's the magic bullet for fact-checking and it's going to completely transform their organization, make them faster, more efficient, have more impact. That can be the case, but only if you have the fact-checking foundations in place. You need to have a strong editorial team. You need to have a robust and transparent methodology. You need to understand the data landscape that you're working in. You need to remember that AI tools are meant to support your work. And if you have good systems in place and good standards, then they will certainly add and have a huge impact and make you faster and more efficient. If you don't have good systems, if your editorial team is weak, if you can't access the data that you need, they're not going to solve those problems for you. So spend the time to get the basics right so that tools like the ones that we've outlined can complement them. Secondly, before I pass over to David for the last piece of advice, is we would urge people not to reinvent the wheel. There are many different organizations apart from PhilFact out there who have spent years developing this type of technology. And there are lots of organizations who you can engage with, to learn with, so that you don't have to start from scratch. Some organizations have code which is open on GitHub that you can look to use to build your own tools. There's been a lot of development in the last few years, and that allows you really to take a big step forward in anything that you start and learn from a lot of the lessons that other organizations have learned themselves. And of course, you have organizations with PhilFact where we're able to offer you the tools on a paid for service, so that you don't need to bring tech in-house or data science experience in-house. And we really have a plug and play system that you can use from day one. David?
Yeah, I would say, as Kate mentioned at the end there, the technology has been improving massively over recent years. And many of these models I've been describing, the various BERT models, are available for free. And so it is tempting. And again, I would encourage you to do this if you have the technical skills, to just download them and play around and see what you can do. One thing I've learned over the last 3.5 years now, being at PhilFact, is that being a data scientist like myself gets you so far. You can do the prototyping, do some experiments, but to build a tool which is actually useful to other people, it requires really a whole team, because you need, to be able to get media from somewhere. That means you need somebody who can write the software to scrape an RSS feed for new media and keep track of that. Even when an article gets updated, you don't want to get a duplicate copy of it. And that requires a whole set of skills around sort of web scraping and content storing in databases, indexing. And a tool which does something really clever, but with a really bad interface, no one's going to use it, especially not in a busy newsroom with busy fact checkers. And so having web developers and user interface designers and UX specialists who can really help you design an intuitive, easy to use tool will actually make it a joy to use. And actually, that's how you get users on board to actually use these tools. So I would say to do a prototype, yes, you can play around with that quite easily, but to build a product which actually is going to be useful, you really need a whole team of data scientists and developers. And also all this requires the support of fact checkers to be able to actually identify the requirements and make sure that we actually are building tools that really do support fact checkers. It's a two-way process. And at PhilFact, we're very lucky to have all those people on board, and funding from Google to carry on doing that for at least the next 3 years. So yeah, please come and talk to us, talk to Kate and me about how we can do these things for you. But that is the end of our presentation. So thank you very much for all your time, your attention, and all your questions. And I think we've got a few more minutes left for any last questions, but thank you.
شكرا جزيلا ديفيد وكيت. هناك الكثير من الأسئلة حقيقة، لكن سأحاول أخذ بعض الأسئلة سريعا. كرم يسأل: هل يمكن معالجة المعلومات الصادرة عن الآلة والمقصود فيها عمدا إرسال معلومات مغلوطة؟
So machines meant sent incorrect. So I'm not sure I understand the question. Sorry.
Yeah, sorry, I didn't understand
هل
the question
يمكن
either.
معالجة المعلومات الصادرة عن الآلة والمقصود فيها عمدا إرسال معلومات مغلوطة؟ يعني إن كان بعض الجهات تستخدم الذكاء الاصطناعي لإرسال معلومات مغلوطة، كيف يمكن حل هذا الموضوع؟
Okay, so I think what maybe asking is, can these same technologies be used to generate false information? And answer is, some say yes. NLP is a kind of two-way street. You can use very similar technologies to interpret text, to understand it, to extract information, verify it. That's what we're doing. The same technology can be used to generate false information and post it. And yes, these large language models like BERT can be used to generate false text, which people can then post onto Reddit or Twitter. And yeah, sadly, that is getting more and more realistic, and is perhaps a challenge to fact checkers and to the social media platforms. how to identify and try and cut out that kind of false information being generated by machines. That's, I think, the subject of a different talk, though.
Okay, Malak is asking, since language seems to be a big barrier, does this mean that claims from the non-English speaking world will not be fact-checkable?
There are fact-checking organizations in many countries in many languages. Our technology, as I'm saying, currently works in English. We are making it work. We are going to make it available in other languages as soon as we can, basically. Watch this space.
ديفيد وكيت، سؤال أخير لكما. الكثير من الحاضرين يسألون متى ستكون هذه الأدوات متوفرة للجميع، لجميع مدققي المعلومات ولجميع المؤسسات تدقيق المعلومات في العالم أجمع.
So currently, David and I are undertaking a process of conducting research on the opportunities and challenges when it comes to making these tools multilingual. And part of that is looking at global fact-checking organizations to identify the different language groups, the regions they're in, so that we can make smart choices about where we expand to first to maximize the impact for organizations. We are, by the end of this year, going to complete a roadmap for next year that will outline the work that we intend to do. Unfortunately, this process is going to take time. I expect that we would probably look to expand to our first new languages by the middle of next year. But when it comes to other languages like Arabic, we are also likely to look for partners to assist us in the development. And in return for that assistance, we would look to waive the monthly subscription fee. So we would look for an Arab fact-checking organization who wants to use this type of technology, but would be willing to help us to refine it and to improve it so that it actually provides good quality output. So please, I've dropped my Twitter account in the chat. I'll put it in there again. Please follow me. Please DM me if you have questions. And then I can also put you on a mailing list so I can inform you when we're looking to expand.
ديفيد، هل تريد أن تضيف شيئا على مقالات فوكيت؟
Only that, yeah, we're very much looking forward to working with fact checkers and looking forward to making these tools more widely available.
شكرا لكما جزيلا ديفيد وكيت، سعدنا بوجودكما معنا هنا. كانت جلسة مفيدة جدا، والكثير من الحاضرين والحاضرات يشكرونكما بشدة في الشات ويقولون أنها كانت جلسة مفيدة جدا لهم. طبعا ندعوكم جميعا إلى تعبئة استمارة التقييم التي أرسلها زملائي في الدعم التقني في الشات، بالإضافة إلى مشاركتنا في الويبينار السادس من مشروع دليل، والذي سيكون في نوفمبر، في 2 نوفمبر عند الساعة 6 مساء بتوقيت عمان. وسنكون مع فريق ميديا ديفانس لنتحدث عن كيف يمكن أن يحمي مدققو ومدققات المعلومات أنفسهم قانونيا. أشكركما، وأيضا أرسل زملائي في الدعم التقني الرابط في الشات، فنرجو منكم التسجيل. أشكركما مجددا كيت وديفيد، كانت جلسة مثمرة جدا، وأشكر جميع الحاضرين على وقتهم وأسئلتهم القيمة التي نعتذر أن لم نستطع الإجابة عنها جميعها. شكرا جزيلا لكم وتصبحون على ألف خير.
Thank you, everyone. Goodbye.
Shukran. Good night.